Going to talk about the Intel 8085 microprocessor architecture. So what is a microprocessor? Well, a microprocessor is an IC that will have a single IC with 40 pin. The 8085 is 40 pin, and the microprocessor is basically this IC with ALU, some timing and control unit, and some registers. This with system bus, RAM, ROM and IO devices constitute a microcomputer. So of course a microprocessor is this single unit, while a microcomputer is this microprocessor and all other these peripherals. This whole total thing is a microcomputer. Okay, so here is a basic difference between the microprocessor and the microcomputer. Now, what is a microcontroller and what are the differences? Well, a microcontroller is one single IC. It's just one single IC that will have the processor unit, some RAM and IO built in it. Now, what is the difference between these two, the microcomputer and the microprocessor? Well, the basic difference lies in the fact that this microprocessor computer with the microprocessor will be simply be able to do some greater job. It can handle very heavy task, of course, because let's face it, this microcontroller will have a very little bit of memory and other abilities, because it's just a single IC. Well, and this one is constitutes of hundreds of IC. But microcontrollers also have some advantages, like being single, this single IC, this can fit into any other gadgets and work as a and can be used as an embedded system to control any part of that gadget, while this is generally being too big, can't be fitted into a very compact gadgets. Now let us study a bit about the microcomputer architecture. Well, the microcomputer architecture is simple. We will have one microprocessor here. Let's draw it a big one. Alright, so okay, here is a microprocessor, and we say we have an ALU here and the registers and timing and control unit. Alright, so because this is a microcomputer, we have to show how it will communicate with all the other peripherals. Of course, we know that the processor cannot work by itself. This processor needs data from the RAM, needs to execute some data, then needs to read some data from the output device, input devices, write something to the output devices, etc, etc. So how is this all done? Well, let's demonstrate. Let me show you. There is something along with this in this micro computer, which are, let me first draw them. Suppose we have some input devices, input div, some output devices. Okay, and the memory. Of course, there should be a memory in the microcomputer, and this will constitute of the RAM and ROM. Basically, it's it's basically a read and write memory. So I am just, for sake of simplicity of understanding, let us say this is the RAM, and this ROM is only read only unit. So this is the memory. All right, and okay, let's block it up. Now, how will this processor unit communicate with these? Well, we have something which is called a system bus. Now, in a system bus, we will have will basically have three type of buses. These are address bus. With red I am drawing address bus. A data bus, I will draw it with the black, and a control bus. Let's say this is a control bus. This whole thing constitute of a system bus. Alright, so what are their functions? Well, the address bus is unidirectional. It can only be used to see where are my input devices, output devices, or the memory. The CPU can use this address bus to locate where are my peripherals. So of course we have something like this, the address bus. It can only locate. Okay, so this is the address bus. Now what is the data bus? As you can say, as the name implies, the data bus can be used to read data from the input device, writing data from the input device to the output device, and both read and write data to the memory. Alright, so we are done with the address bus and data bus. Note that this data bus is bidirectional. Sorry for that. Also, now we come to the control bus. So what is this control bus? Well, the control bus enables the timing signal so that the processor can communicate one by one at one time with the input device or with the output device or the RAM. The processor cannot communicate with these all at a single time. With each clock cycle, this processor will communicate with these peripherals. So these things point like this. Okay, so this is an architecture of microcomputer. This stuff is very important for my next lesson, so please get this one straight. Okay, so let us review what we have learned. We have learned about this microprocessor, a brief overview of the microcontroller and the microcomputer, and this architecture of this microcomputer. In my next lesson, we will discuss about the architecture of the 8085 processor with various pin diagram and the function of each pin. See you in the next video.